This is one last fluid pressure example problem. It's actually a group of problems. It's 3 different problems that we're going to look at that use the FR is equal to gamma Z bar A formula to calculate the resultant force on like the end of a tank, where the end of the tank is not a constant width shape. So the end of a tank might be straight, it might be flat, but it's not constant width. And because it's not constant width, we can't use our pressure distribution formula. We can't use F horizontal and vertical. So the only 2 choices we have are to integrate, which is evil, it's doable. You should do it for fun, just for kicks, where you just integrate the integral of pressure times dA over the face of that end of that tank. But it's way easier to just use the F is equal to gamma C bar A formula. So for the purpose of exam review, those problems occasionally show up. I'll review this again for you so you've got that in your toolkit as well. So it's not uncommon to have an exam problem where you have the end of a tank. The tank might be a circle. The tank might be a triangle. The tank might be a parabola. The tank might be a half circle. Because these are not a constant width, we can't use our flat plate constant width formulas. We can't find the volume of the pressure distribution easily. We can't use horizontal and vertical easily. So really only our 2 choices are to integrate or it turns out our gamma Z bar A formula works. So we're going to review the formulas here, then we'll work several examples. So what you're looking for is gamma, which you're given, Z bar, and area. So if you have the end of a circular tank, and for all of these cases, we're assuming the fluid level is at the top of the tank. So the Z bar from the top of the tank down to the centroid is R. The area is pi r squared. For a triangle, the distance from assuming the water's at the top of the tank, the Z bar takes you to the centroid of this triangle, which is 1/3 h. If h is the total height, it's 1/3 h. And the area, of course, is 1/2 base times height. For a parabola, with the water level at the top of the tank, and the total distance is h, the centroid, the Z bar, is 2/5 of h. And the area is 2 times 2/3 of BH, where B is half of this guy and H. And finally, if you have a half circular tank and water comes up to the top, then the Z bar is 4R over 3 pi. And the area, of course, is pi r squared over 2. So end of tank problems. If I scroll this down, we'll work these examples. And so this is a triangle, the end of a tank. It's 1 meter high by 1 meter. Rho is 1,000 kilograms per cubic meter. Gamma is 9810 newtons per cubic meter. Our FR is gamma times Z bar times A. So gamma is 9810. Z bar is 1/3 meter. And the area is 1/2 base times height, or 1/2 1 times 1. And you get FR is 1.635 kilonewtons on the end of this triangular tank. Way easier than an integration. This is a round tank from an old exam. The radius is 0.5 meters. Gamma is 9810 for fresh water. Z bar is 0.5 meters. The area is pi times 0.5 squared. And so FR is gamma times Z bar times area, which is 3.85 kilonewtons. And remember, FR does not act at the centroid. FR acts at the center of pressure, which is below the centroid. Even though we use Z bar to calculate FR, it doesn't act. FR does not act at Z bar. Finally, this is a parabola that was a homework problem. And so the height was 4 feet. This is 2 feet and 2 feet parabola. The gamma in this case was 25 pounds per cubic foot, which is extremely unusual. It's like almost like a foam. It's a very light fluid. I mean, I can imagine it's a foamy fluid, if you will. Z bar is 2/5 of 4, which is 1.6 feet. The area is 2 times 2/3 VH. And of course, our gamma was 25. So the resultant force is gamma times Z bar times area. So the resultant force is 426.7 pounds. So these are end of tank problems. Integration is, you might do for fun, but you certainly don't want to do it on an exam. And just learn to use the gamma Z bar A formula for these end of tank problems, and you're good to go.